Hello everyone, today's lesson is lesson 78, Exponents and Square Roots. When we want to show a repeated addition, we may use multiplication. For example, 5 plus 5 plus 5 would be the same as 3 times 5. To show repeated multiplication, we use something called an exponent. So if we had 5 times 5 times 5, that would be the same as 5 to the third power. This little sign up here is the exponent. And the number down here we call is the base. Okay. The exponent shows how many times we're multiplying the base by itself. Okay. So 5 cubed equals 5 times 5 times 5. All right. So, for example, we have special names for some of these. So this would read as 3 squared. 3 squared is the same as 3 times 3 because the exponent tells us how many times we multiply the base by itself. 3 cubed would be 3 times 3 times 3. Now, squared and cubed are the only ones that have special names. Okay, we have 3 squared because this has reference to area, and 3 cubed has reference to volume, which we'll be talking about later. Okay. All right. So the next one is 3 to the 4th power. Okay, we call exponents powers. So 3 to the 4th power. That is 3 times 3 times 3 times 3 because there are, the 4th power tells us we need to do it 3 times. Okay, 3 to the 5th power is the same as 3 times 3 times 3 times 3 times 3. So notice we have 1, 2, 3, 4, 5 of them because that's what the power tells us to do. Okay, so we could read 3 to the 3 squared as 3 to the 2nd power, but we say squared when the exponent is a 2. Okay, so 3 squared would look like this. And it looks like the area, okay? Because this would be 3 times 3 to find the area of this circle or this square. Or we do 3 squared, okay? So the area of this square would be 9. 3 times 3 is 9. Now 3 cubed references a cube, which has to do with volume, because we have each edge of a cube is 3 units long. So this would be 3 cubed, or 3 times 3 times 3, which is the same as 27 units. So there'd be 27 blocks in here that I could count. All right, so this says write 3 cubed as a whole number. So we multiply 3 3's together. 3 times 3 times 3. Well, 3 times 3 is 9. Times 3 is 27. So my answer would be 27. So this says if 2 times n equals 6, what does n squared equal? So we have to take 2 steps. So remember, the expression 2n is the same as 2 times n, right? Or the same as n plus n. All right? So if 2n equals 6, then we are thinking 2 times what equals 6? Well, 2 times 3 equals 6. So n equals 3. Now I know what n equals. So n equals 3. So now I want to know what n squared equals. So n squared would be the same as 3 squared. 3 squared is the same as 3 times 3. And 3 times 3 is 9. So my answer would be 9. Okay. So when we evaluate an expression, we're finding the value of it. So here are some powers of 10. We have 10 to the 1st power, 10 squared, 10 cubed, and 10 to the 4th power. So when we evaluate each expression, we're going to write the power as a whole number. So 10 to the 1st power means there's just only one 10. So 10 to the 1st power just equals 10. 10 to the 2nd power would be 10 times 10, which is equal to 100. 10 cubed is the same as 10 times 10 times 10. Well, 10 times 10 is 100, times 10 is 1,000. And then 10 to the fourth power equals 10 times 10 times 10 times 10. And that equals 10,000. Now, if you notice, there's a pattern here. When we are dealing with tens, powers of 10, the power tells us how many zeros there are. 10 to the first power, it's just 10. 10 to the second power is 1 with 2 zeros, 3 zeros, and 4 zeros. Okay, so powers of 10 can be used to show place value. And you can see that from here. The ones place is 10 to the 0 power because a 1 looks like this, and there are 0 zeros after it. Okay, so 10 to the 0 power is just 1. 10 to the first power is the tens place. 10 squared is the hundreds. 10 cubed is thousands. 10 to the fourth power is 10 thousands. 10 to the fifth is 100 thousands. 10 to the sixth is millions. 10 to the seventh is 10 millions. And 10 to the eighth is 100 millions. So if I wanted to write a number in expanded notation using the powers of 10, it would look like this. So we have 4,500,000. So normally we would write 4 times 1 million. Oops. There we go. Plus 5 times 100,000. All right. Well, instead of writing these really long numbers, I can use a power of 10. So what I do is I replace the second number here, the 1 million, with its power of 10. So going back, you see that 1 million is the same as 10 to the sixth power. So this would be 4 times 10 to the sixth power plus, and we know that because look how many zeros we have. We have 1, 2, 3, 4, 5, 6. So it's 10 to the sixth power. Okay, plus 5 times 10 to what power? Well, the trick is you count how many zeros. 1, 2, 3, 4, 5. So it would be 10 to the fifth power. Okay. All right. So this next part is talking about square root. If I know the area of a square, then I can find the length of each side. So let's say that a square has an area of 36 centimeters. How long is each side? Well, I know that area equals length times width. And since it's a square, both these numbers have to be the same. So I'm looking for two numbers that multiply together equals 36. And it has to be the same number. So I know that 6 times 6 equals 36. So if I'm going to have my square, the length of each side is going to be 6 centimeters. Okay. So we call this a square root. So if I say what is the square root, and that's what this symbol is. This symbol here is called the square root symbol. It looks like a funny division symbol that has like this little tail. Okay. So the square root symbol indicates the positive square root of a number. So the square root of 36 equals 6 because 6 times 6 equals 36. Okay. So we say the square root of 36 equals 6. So this problem says find the square root of 100. Well, the square root of 100 is 10 because 10 times 10 equals 100. It's kind of doing the opposite of a square. Okay. The perfect squares have a whole number square root. So here I've got part of my multiplication table. And the perfect squares are always shown as shaded in a diagonal line. So if I asked you what the square root of 1 is, you would tell me it was 1. The square root of 4 is 2. The square root of 9 is 3. The square root of 16 is 4. and the square root of 25 is 5. Okay, so this problem asks, compare the square root of 9 plus 16 and the square root of 9 plus the square root of 16. On the left, since these two numbers are under the same square root, I need to add them first. So 9 plus 16 is 25. So I need to find the square root of 25. And then on this side is the square root of 9 plus the square root of 16. So the square root of 25, if we go back and look, the square root of 25 equals 5. Okay. And then we have the square root of 9, which is 3, plus the square root of 16, which is 4. 3 plus 4 is 7. So which is bigger? Well, 7 is bigger than 5, so we would say 5 is less than 7. Okay, and that's it for this lesson. Good luck on your homework.